He's the founder of the Fire Safety Engineering Group here, and apart from all the academic work and the modelling that we've been hearing about, he's really a very well recognised world expert now, and he through a series of big prestigious national and international awards that his group and himself have received, and he serves on a number of national and international standards and safety committees concerned with fire and evacuation, including BSI, ISO, IMO and the SFPE. Ed.
Thanks, David. Right, I'm going to give you a talk this afternoon about the use of computational fire engineering tools to forensic analysis. CFE is a term I coined about a year ago to describe the use of fire models, evacuation models, structural models to fire engineering. So computational fire engineering is, I believe, a discipline in its own right. And we're going to be looking at the use of computational fire engineering in forensic fire analysis. I want to acknowledge my co-authors, especially Mr. Zhang, who's my PhD student, who did all of the evacuation modeling work here, and also my colleague Dr. Jia, who ran the fire simulations. I also want to acknowledge our cooperation and our work with SP in Sweden and Dr. Ingerson in particular, who made this data available to us. I'm going to be describing the Gothenburg incident, something about the hazard data that we've got from SP about the incident. I'm going to very, very briefly talk about Exodus and CFast, and then I'm going to look at some simulations that we've done using CFast and Exodus to look at some of what happened in this tragic incident. In particular, I'm going to look at trying to reproduce the original incident to try and understand what caused it. And then I'm going to look at what would have happened, for example, had they followed the regulatory compliance, had they actually had regulatory compliance. And then what would have happened, for example, if we had put in an additional exit. And then hopefully I'll finish up with some conclusions. There's a growing area of interest in the use of CFE tools for forensic fire analysis and incident investigation. I think this is a very exciting area because the tools give us insight into what's going on, and so hopefully we'll be able to better understand the outcome of some tragic events and maybe even help solve some criminal situations and understand what led to the development. However, this is generally quite a difficult process because usually when we're looking at reconstructing real incidents, the initial and boundary conditions are not usually known, and so that makes it very difficult to set up your models. Actual as opposed to design scenarios usually vary very dramatically, and they can be very, very complex. And they often involve phenomena beyond the current predictive capabilities of models. And so we've got to be very, very careful when we're using these tools to try and come to some conclusion in some of these forensic fire investigations. So this means when using CFE for forensic analysis, it's essential that the simulation results are viewed as indicative rather than being conclusive. In many cases, CFE can be used to rule out possibilities rather than to say what actually happened and how it happened. Perhaps you can use it to rule out some possibilities that have been put forward. As forensic fire analysis usually involves a known outcome, it may be possible to use CFE to suggest factors likely to exert an influence on those outcomes. And so we can, if you like, do sensitivity analysis around the incident. The case we're going to be looking at here is the Gothenburg Disco incident of 1998. We're going to attempt to utilize small-scale fire experiments that SP conducted as part of the investigation. We're going to do some fire simulation work, not using our Smart Fire CFD model, but using CFast's own model. And we're going to do some evacuation analysis and combine the fire with the evacuation analysis. Again, I really want to emphasize this word of caution. Given the unknowns associated with the incident, and given the process involved in manipulating the fire hazard data, we have to be careful the conclusions we draw from this investigation. And it's only possible to assert that we are investigating a Gothenburg type of incident rather than the Gothenburg incident itself. But we hope that this will allow the identification of issues associated with this incident and more generally those issues associated with using CFE tools for forensic fire analysis. Just to recap the Gothenburg incident, it took place on the 29th of the 10th, 1998. It was a disco hall in Gothenburg. It was estimated that there was something like 400 people in the building, whereas the occupancy was approved for 150. The upper floor of the building where the disco was taking place was actually an old industrial building, and 63 people died in the ensuing evacuation and about 180 were injured. Fatalities were located around the external exit and in side rooms where they had sought refuge as they were trying to get out. The NSPA concluded that the tragedy was a result of overcrowding, lack of a fire alarm, and loss of an external staircase. This tries to encapsulate the whole process. The fire started on a staircase which was blocked. The door was open to the staircase, and so fire burst into the disco hall room. This rapidly spread, forcing people to evacuate using the only viable staircase that was left. Some people sought refuge in these side rooms, and this led to a number of fatalities, and especially bodies piled up by just inside this internal exit. This